Hello everyone, welcome to Python All Day. Today I want to talk about PyTorch, and this is the first of a series of different video segments where I'll be talking about PyTorch. We'll start from zero to hero with PyTorch. So we'll start with the basics. This video is pretty much going to be more about the theory and a little bit of getting to know what PyTorch is and how we can use it in machine learning and deep learning and also in training neural networks in computer vision, things like that. So it's going to be more of talking about just the theory, and maybe in about after this video and maybe another video, we will go ahead and start with actually creating neural networks by writing code. It's going to be very code intensive once we start coding, because everything else after that it's pretty much going to be coding. But anyway, let's go ahead and get started. Number one is definitions. And you may ask, what is PyTorch? So essentially, PyTorch is an open source machine learning library that was developed by Facebook AI research team or research lab. And it is, or rather, it is flexible. And also it provides an efficient environment for building and training neural networks. As we run through the definitions, I just want to keep it a little bit short because it's very easy to get distracted, and we'll talk about neural networks as we continue on the course. But for now, the most important thing to get here is that it's an open source machine learning library that was developed by Facebook, and it provides a flexible and efficient environment for building and also training neural networks. And PyTorch is normally used for tasks like natural language processing. And natural language processing is essentially, it's like teaching computers to understand and work with human language, just the way we as humans do. With regard to natural language processing, it's good to think of it, or rather to think about when you type a question in a search engine and it gives you answers or suggestions. In that aspect, natural language processing helps computers understand what you are asking for, and also to process the text that you typed and also give you relevant results. I'm going to go a little bit on the natural language processing. It involves a bunch of cool stuff like understanding the meaning, in that it helps computers figure out the meaning behind words and sentences. And also it can also help with language generation, as we have seen now with the introduction of ChatGPT and other generative AIs. It is not just about understanding, but NLP, or natural language processing, also helps computers generate human-like text. This is very relevant now in the age of ChatGPT. For instance, it might write news articles or even chat with you, obviously. And also natural language processing can also help with translation and also with sentiment analysis. And natural language processing can understand the emotions behind words, and in that aspect, it can tell if a review of a movie, for instance, is positive or negative, or if a review in Amazon products is positive or negative. So PyTorch is normally used in natural language processing, also in computer vision. Think of self-driving cars, and also in reinforcement learning. And this is more involves about things like items in robotics. So PyTorch is also, one other thing that I wanted to mention is that one of the key advantages of PyTorch is its dynamic computation graph, which allows for more flexibility and for ease with debugging during model development when compared to static computational graphs. The dynamic nature of PyTorch enables developers to change the structure of the neural network on the fly, which is particularly useful in scenarios like building recurrent neural networks or models with varying input sizes. So, a quick question, a quick thing that I wanted to talk about is about the dynamic computation graph. What is it, and how is it relevant to PyTorch? A very easy way to think about it is essentially dynamic computation graph is essentially like a roadmap that a computer uses when it's trying to figure out how to solve a problem step by step. Unlike a regular roadmap that's fixed, a dynamic one can change as the computer goes along. Like, for instance, imagine that you are trying to solve a maze, and each time you take a step, you decide which direction to go next based on where you are currently. If you hit a dead end, you backtrack and try a different path. So that's similar to how dynamic computation graph works, in the sense that each time you take a step, you decide which direction to go next based on where you are. And if you hit a dead end, then you can backtrack to try a different path. And that's essentially similar to how a dynamic computation graph typically works. And in computer terms, when a program runs, it might make decisions at each step based on the data it's working with. And these decisions can change the structure of the computation graph as it goes along. And this flexibility is very useful in tasks like machine learning, where the program might need to adjust its calculations based on new information that it receives. So that's dynamic computation graph. And PyTorch has one of the key advantages being its dynamic computation graph, which allows for more flexibility and ease of debugging during model development compared to static computation graphs. And what is static computation graphs? I think that's something else that we can also talk about. And essentially, since we have talked about dynamic computation graphs, I think it's helpful to also try to see what static computation graphs is or graphs are. So static computation graphs are like blueprints that computers use to plan out how to solve a problem before they actually start doing the work. It's kind of like drawing a map of all the steps you need to take to solve a puzzle before you begin putting the pieces together. Or imagine that another way is maybe to imagine that you have a recipe to bake a cake, but before you start baking, you write down all the ingredients and also the steps in order. You don't change the recipe of the cake as you go along. You stick with the plan that you made at the beginning. So in computer terms, when you are using a static computation graph, you lay out all the steps of your calculations in advance, and each step depends on the results of the previous ones. So you have to plan everything out carefully before you start. This approach is useful for certain kinds of tasks where you know exactly what you need to do ahead of time and don't expect things to change while you are working and static. So, as we were saying, one of the key advantages, as you can see here, of a PyTorch is its dynamic computation graph, which allows for more flexibility and ease of debugging during model development compared to static computation graphs. The dynamic nature enables developers to change the structure of the neural network on the fly, which is particularly useful in scenarios like building recurrent neural networks. We'll talk about recurrent neural networks or models with varying input sizes. We'll also talk about that. I can explain everything as we go, but some of these things we will actually be able to get deeper into them. And we'll be working with the recurrent neural networks as well as convolutional neural networks once we start with writing code. So I'll just try to peruse over these definitions so we can be able to go and get close to starting to code. Another way to think of PyTorch is that it provides a rich set of tools and modules for building deep learning models, and we'll talk about deep learning, try to see what deep learning is, including tensor operations, automatic differentiation, and various optimization algorithms and neural network layers. Again, we'll talk about neural networks as we go along. Another way to think about Python and why really we should be able to utilize PyTorch is that it offers seamless integration with other Python libraries such as NumPy. So overall, Python has gained popularity within the machine learning community because of its simplicity, flexibility, as well as performance, and it's often the framework of choice for researchers and also for practitioners alike. We go next here. We want to see what is PyTorch used for. I'll just run through this very quickly because we'll be able to talk about this further once we start writing the code. But PyTorch is used for a wide range of machine learning and deep learning tasks, including and not limited, obviously, to neural network implementation. And PyTorch provides tools and modules for building neural networks of various complexities, from simple feed-forward neural networks to complex architectures like convolutional neural networks. We'll learn about this pretty intensively. And also recurrent neural networks, which are also called RNNs, and transformers. I can maybe try to expound a little bit more about what a neural network is. So at least as we talk about neural networks, we can be able to essentially have a little bit of an idea of what we're talking about. So a neural network in machine learning, deep learning, is it's neural networks essentially are used for all kinds of tasks in machine learning, deep learning, like recognizing objects in images or understanding language, in NLP, or making predictions and etc. They are really powerful because they can learn to do complex things without being explicitly programmed for each task. And that's the beauty of machine learning and also deep learning and neural networks. I can go to Google and I can just try to see what Google can say about a picture. Maybe we can see a picture of neural networks, and so this is, we can go to images here, and obviously this is all neural networks. I want to just look for a simple one here. There's this one here where you have a simple neural network, and you can see here there is a layer, and we'll talk about this as we continue with our PyTorch video series. But you have an input layer here for your simple neural network, then you have an hidden layer here, and then you have the output layer. In neural networks, you can have multiple hidden layers. As you can see here, we have this input layer, then we have this hidden layers. We have one hidden layer here, and we have another hidden layer here, and then we have the output layer here. So this is a neural network with two hidden layers. You can have multiple hidden layers. This is another neural network, artificial neural network. You anticipate that this is the input layer, then you have the hidden layers here, three of them, then you have the output layer. Just want you to get a little bit of an idea of what a neural network is. We'll talk about the forward propagation, where we send information this way, and we'll also talk about the backward propagation. We'll also talk about weights optimizers, and when we start training and when we start building and also training our neural network. But for now, I don't want to get too deep. I just want to stick with the with the introductions, and I just wanted to show you a little quick example of what a neural network is. But essentially what you can take from that is neural networks are normally used in all kinds of tasks in machine learning, in deep learning, like recognizing objects in images. Like you want to recognize, is this a cat, is this a dog, or it's not a cat, or it's not a dog. Or you want to use it to understand language, like the ChatGPT, or to make predictions, like maybe they can use it in the stock market and things like that. And they are really, really powerful. Neural networks are really powerful because they can learn to do complex things without being explicitly programmed for each task, you know. So I think that's a truly powerful thing. But we go back to our slides here. I want to go back to the slide view. I'm going to go to view and also slideshow. And so PyTorch is used for neural network implementation, as we have seen. It normally provides tools and modules for building neural networks of various complexities, from simple feed-forward neural networks to complex architectures like convolutional neural networks or CNNs, recurrent neural networks like RNNs, and also transformers. Um, Another use for PyTorch is in natural language processing, or NLP. And PyTorch is used in natural language processing, or NLP, tasks like text classification, sentiment analysis, and also machine translation, named entity recognition, and also text generation. Its flexibility, PyTorch flexibility makes it particularly suitable for working with sequential data like text. PyTorch is also used in computer vision, and as you can see here, it's extensively used in computer vision tasks like image classification, object detection, image segmentation, and also image generation. Its ability to handle convolutional neural networks efficiently, or CNNs efficiently, make it a popular choice in the domain of computer vision. You may ask what computer vision is, and easy way to kind of like try to think of computer vision. It's like more or less giving computers eyes to see and understand the world, just like we do. It's a field of artificial intelligence that focuses on enabling computers to interpret and understand visual information from images or videos. Uh, Again, it's normally used in many real-life applications like object recognition, that's identifying objects or images or videos, or rather identifying objects in images or videos, like recognizing faces in photos or detecting cars in traffic. It's also used in image, computer vision is also used in image classification, where you can be able to use it to sort images into different categories, such as determining whether an image contains a cat or a dog. It's also used in object tracking, computer vision, where you can be able to follow the movement of objects in videos, like tracking the trajectory of a basketball during a game. And also computer vision can also be used in real life applications like understanding scenes, or rather understanding the context and the content of a scene, like under define a room's layout, or understanding the activities that are happening in a video. So computer vision more like giving computers eyes to see and understand the world just as we as humans do. Um, Another area where PyTorch is used is in reinforcement learning. And you ask, what is reinforcement learning? But before we go to defining the reinforcement learning, you just can understand that reinforcement learning, or rather, PyTorch provides tools for implementing and training reinforcement learning algorithms. And it is used in developing and training engines to interact with environments such as in gaming AI, in robotics, or in optimization problems. So reinforcement learning, the way to understand it, and we'll talk about this a little bit more as we continue to dig deeper in PyTorch. But the way to understand it is that reinforcement learning is essentially like teaching a computer to learn from its own experiences, just like we as humans learn from trial and error. So in reinforcement learning, the computer is, or in reinforcement learning, the computer is like, just think about when you're training maybe a puppy to do tricks, and when the puppy does something right, like sitting, when you say sit, or you give it a treat. And when it does something wrong, like jumping on the furniture, you might ignore it or give it a gentle correction. So over time, the puppy will learn which behaviors get rewarded and also which behaviors don't get rewarded. And in that sense of whereby you are training a puppy on new tricks like sitting, and in reinforcement learning, the way to think of that is that the computer is like the puppy, and it's trying to figure out the best actions to take in a certain situation to maximize a reward. So the computer tries different actions, and based on the feedback it receives, it learns which actions lead to better outcomes. Reinforcement learning is used in various applications, such as game playing, where you can teach computers to play games like chess, Go, or video games, and they can learn from their wins and losses to improve their strategies. Also, reinforcement learning is also used in robotics, where you train robots to perform tasks like walking, grasping objects, or navigating through environments by rewarding successful actions and penalizing failures. Also, reinforcement learning is also used in autonomous vehicles, where teaching self-driving cars to make decisions on the road, like navigating traffic or avoiding obstacles by learning from driving experiences. So overall, most important thing to understand is that reinforcement learning is a powerful approach that allows computers to learn how to make decisions and take actions in complex environments through trial and error, and obviously rewards, and ultimately they improve their performance over time. Reinforcement learning. So PyTorch is used in reinforcement learning, and also PyTorch is also used in generative models. And PyTorch is used for building generative models like generative adversarial networks or GANs. We'll see this as we continue with our PyTorch journey. Also, other generative models could be variational autoencoders or VAEs and flow-based models. And these models are used for tasks like image generation, style transfer, or data augmentation. We'll talk a little bit more about this as we go along. The other thing I want you to know is that Python can also be used for transfer learning, and or rather PyTorch, sorry, can be used for transfer learning, and this and it can in that way facilitate transfer learning where pre-trained neural network models are fine-tuned or new data sets for specific tasks. This approach is commonly used to achieve better performance on tasks with limited data or computational resources. A very easy way to understand transfer learning, I'm just gonna mention this as we go, so you can be able to kind of like get a little bit of just a basic understanding. It's that transfer learning is like using knowledge you already have to learn. I mean, I'm going to say this again just so I don't confuse. Transfer learning is like using knowledge you already have to learn something new more quickly. Like, for instance, imagine that you are learning to play the piano and you are already pretty good at the guitar. Because you understand music theory and have experience with one instrument, you can apply some of that knowledge to learn the other instrument faster. So, in the world of artificial intelligence and machine learning, essentially transfer learning works similarly. So, instead of starting from scratch every time you want to train a new model for a specific task, you take a pre-trained model that has already learned from a large data set and you fine-tune it for your particular task. For example, let's say that you have a pre-trained model that's really good at recognizing different types of animals in images. So if you want to build an app that identifies specific breeds of dogs, instead of training a new model from scratch, you can start with a pre-trained model and then teach it the specific differences between dog breeds. So this way you save time and also computational resources because the model has already learned some general features about animals. So another thing to kind of like understand is that transfer learning is widely used in various applications, including computer vision, natural language processing, and speech recognition. It's a very powerful technique that leverages existing knowledge to solve new problems and new problems more efficiently. So that's transfer learning, and PyTorch is used also for transfer learning. And also PyTorch is also used for research and development. And as a matter of fact, PyTorch is very popular among researchers and practitioners because of its flexibility, ease of use, and also dynamic computation graph. It is widely used for experimenting with novel architectures in algorithms and also ideas in the field of machine learning and artificial intelligence. So overall, PyTorch is a versatile framework that finds applications across various domains in academia, research, and industry, owing to its powerful capabilities and ease of implementation. We can say which companies use PyTorch. Right now, like it's a lot of companies use PyTorch. Facebook, Tesla with their driving cars, Microsoft, Nvidia. So there are a lot of companies that currently use PyTorch, and it's becoming popular in the industry of machine learning and artificial intelligence. So why should you use PyTorch? Or why should a company or industry use PyTorch? As we have said, one way is that there are several reasons why you might consider using PyTorch for your machine learning and deep learning projects. One is dynamic computational graphs. PyTorch utilizes dynamic computational graphs, which allow for more flexibility and also for intuitive model development compared to static computational graphs used in some other frameworks. And this dynamic nature makes PyTorch easier to debug and also to experiment with other models, particularly those involving recurrent neural networks or RNNs or architectures with varying input sizes. So that's one reason, dynamic computational graphs. We have talked about just a little bit defined dynamic computational graphs and also static computational graphs. But PyTorch utilizes dynamic computational graphs, and it makes it a little more flexible and also intuitive to use. Also, another reason why you might consider maybe using PyTorch is because of the Pythonic interface. And PyTorch normally provides a Pythonic interface that is intuitive and also easy to use. And this makes it accessible for both beginners and experienced developers, allowing for rapid prototyping and also experimentation. Another reason you may want to use PyTorch is the ecosystem and also the community. So PyTorch has a vibrant and growing ecosystem supported by a large and active community of developers, researchers, and also practitioners. So this community contributes to the development of libraries, tools, and tutorials, and also providing resources, making it easier to find help and also to collaborate on projects. Another reason why you may maybe consider using PyTorch is the native GPU acceleration. So PyTorch offers seamless integration with NVIDIA GPUs through its Kunda backend, allowing for uh, efficient parallel computing and accelerated training for deep learning models on GPUs. So, what is the Kunda backend? What's Kunda? Maybe we can try to see what Kunda is before we kind of like go further. Um, very easy way to think of Kunda is essentially I'll say, maybe I'll tell you, it's actually it's an abbreviation which stands for Compute Unified Device Architecture, and it's a parallel computing platform and application programming interface, or API model that was created by NVIDIA. So the way to think of Kunda, and I'll just be a little bit fast here, but imagine that you have a really powerful tool like a magic wand that can help you to do many things at once. In the world of computing, GPUs, or graphics processing units, are pretty much like those magic wands, and they are specialized processors originally designed to handle graphics related tasks like in gaming, but they are also incredibly good at handling lots of calculations simultaneously. So essentially, Kunda is like the language that lets programmers speak to these GPUs. The GPUs, the graphics processing units, as opposed to CPUs. And so Kunda is like the language that lets programmers speak to these GPUs. It allows developers to harness the immense processing power of GPUs for general purpose computing tasks, and not just graphics. So this means that you can use GPUs to speed up all kinds of computations, from scientific simulations and machine learning to video processing to cryptography. So basically, Kunda enables programmers to tap into the super fast parallel processing capabilities of GPUs to accelerate their applications and solve complex problems more efficiently. But so Python, or rather PyTorch, normally offers a seamless integration with NVIDIA GPUs through the Kunda backend, which allows for efficient parallel computing and accelerated training for deep learning models on GPUs. And also, another reason why you may consider using PyTorch is the dynamic neural networks, in the sense that PyTorch's dynamic neural network nature, or rather, PyTorch dynamic nature enables the creation of dynamic neural networks where the structure of the network can change during runtime based on input data or even other conditions. And this flexibility is very useful for tasks like adaptive computation, attention mechanisms, or reinforcement learning. And another reason why you may consider using PyTorch is the rich functionality and libraries. So PyTorch provides a rich set of tools and libraries for building and training deep learning models, including tensor operations, We'll talk about tensor in maybe in about next video or the one after that. But just want you to know that PyTorch provides a rich set of tools and libraries for building and training deep learning models, including tensor operations, automatic differentiation, various optimization algorithms, and we'll see this as we continue with our PyTorch journey, and also pre-trained models. Additionally, PyTorch integrates well with other Python libraries like NumPy, SkyPy, and scikit-learn. So next, I want to talk about another reason why you may want to use PyTorch is that it's research focused, and PyTorch is widely used in academic research and is preferred by many researchers for its flexibility, expressiveness, and also ease of experimentation. Its dynamic computational graph and intuitive interface makes it well suited for exploring novel architectures, algorithms, and ideas in the field of machine learning and also artificial intelligence. So overall, PyTorch offers a powerful and flexible framework for building, training, deploying deep learning models, making it a popular choice among researchers, developers, and practitioners in the machine learning community. And next, we can talk about differences between PyTorch and TensorFlow. TensorFlow is another machine learning, deep learning framework that is used to pretty much accomplish most of the things that PyTorch is also used for. TensorFlow was developed by Google. Python was developed by Facebook or Meta, currently Meta. So both PyTorch and TensorFlow are popular deep learning frameworks, and each has its own strengths and characteristics. So I'm just gonna try to go a little bit very quick and just highlight for you some of the key differences between PyTorch and TensorFlow, but similarities. They are both used in deep learning, machine learning. And one thing to know about TensorFlow is that TensorFlow primarily uses a static computational graph. And we saw about the static computational graph when earlier on in this video. But TensorFlow primarily uses a static computational graph where the graph structure is defined upfront and then executed. This approach can offer optimizations for performance and deployment. PyTorch, on the other hand, utilizes a dynamic computational graph where the graph is built dynamically and operations where the graph is built dynamically as operations are executed. So this flexibility allows for easier debugging and also for more intuitive model development. So TensorFlow primarily uses static computational graph. PyTorch uses a dynamic computational graph. We saw about both dynamic, or rather defined, both the dynamic computational graph and also the static computational graph earlier on in this video. So our next difference we can look maybe between TensorFlow and PyTorch is the ease of use. So TensorFlow can have a steeper learning curve due to its static graph nature and sometimes verbose syntax. However, with TensorFlow 2.0, which introduced a more user-friendly API, or rather, however, TensorFlow 2.0 introduced a more user-friendly API similar to PyTorch dynamic approach. And PyTorch is often praised for its simplicity and also Pythonic interface, which makes it more accessible to beginners and also facilitates rapid prototyping and experimentation. Another difference that we can look between PyTorch and TensorFlow can maybe be on model deployment. So TensorFlow offers robust tools and libraries for deploying models in production environments like TensorFlow serving for serving models via APIs and also TensorFlow Lite for deploying models on mobile and edge devices. While PyTorch provides deployment options, TensorFlow's ecosystem and tools for deployment are generally more mature and also extensive. Another way we can look at the differences between PyTorch and TensorFlow would maybe involve the community and the ecosystem. So TensorFlow has a larger and more established community with extensive documentation, tutorials, and resources available. It also benefits from strong industry support and adoption. PyTorch, on the other hand, PyTorch's community has been rapidly growing, particularly in the research community. It is favored by many researchers for its flexibility and dynamic nature, as we have been saying, and it has gained popularity in academia and also among practitioners. Another way we can maybe try to see about some differences between PyTorch and TensorFlow would be in the integration with other libraries. TensorFlow integrates well with other Google products and services. Remember, it was developed by Google. So TensorFlow integrates well with other Google products and services like Google Cloud Platform, making it convenient for building end-to-end machine learning libraries, or rather machine learning pipelines, sorry. On the other hand, PyTorch integrates seamlessly with Python libraries such as NumPy, making it easy to combine with other data processing and scientific computing tools. And another way I wanted to look about the differences between TensorFlow and PyTorch is with regards to debugging and visualization. TensorFlow offers built-in tools for debugging and visualization, such as TensorBoard, which provides interactive visualization of training metrics and computational graphs. PyTorch, on the other hand, its dynamic nature can simplify debugging as developers can inspect and modify the computation graph more easily during runtime. However, PyTorch may lack some of the comprehensive visualizations visualization tools that are available in TensorFlow. So basically, TensorFlow and PyTorch are both powerful frameworks with their own strengths and use cases. TensorFlow may be preferred for its static graph optimization and also mature deployment ecosystem, while PyTorch is favored for its simplicity, flexibility, and dynamic approach to model development. But ultimately, the choice between the two often depends on factors like project requirements, personal preference, and also community support. But for the most part, it's the concept is pretty much the same. And once you learn one framework, either PyTorch or TensorFlow, you find that they pretty much work more or less the same. It's just a little bit of some conventions here and a little bit of specifics here and there. But for the most part, the big concept, TensorFlow, PyTorch, it's more or less all the same. And for building these machine learning neural networks. So we have been talking about machine learning and deep learning, but we haven't really taken some time to define, because machine learning and deep learning are not essentially the same thing, but they are related. So I just want to take this time to just a little bit try to introduce you to machine learning and define what machine learning is. And after this, we'll also talk about deep learning as well, because they're different but related. So to start with, machine learning is a subset of artificial intelligence that focuses on the development of algorithms and statistical models that enable computers to learn from and make predictions or decisions based on data without being explicitly programmed for specific tasks. The primary goal of machine learning is to enable computers to learn from experience, trial and error, to recognize patterns in data, and also to make predictions and decisions that improve over time. And there are different types of machine learning. There's one called supervised learning. Another type of machine learning is unsupervised learning. Another type of machine learning is semi-supervised learning. And another type of machine learning is reinforcement learning. So we'll start in the next slide. We will discuss about all these kinds of machine learning one by one. So I will see you in the next slide. Already, welcome back. We were talking about the different types of machine learning. We saw that we have supervised learning, we have unsupervised learning, we have semi-supervised learning, and we also have reinforcement learning. So in supervised learning, if I can say, is that in supervised learning, essentially, uh, the algorithm is trained on a labeled data set. That's very important. Labeled data set, meaning that we already know what the item is. If it's a cat, we know that we have a picture of a cat and we know that this is a cat. We have a picture of a dog, we know that this is a dog. We have a picture of a donkey, we know that this is a donkey. So the labels, that's the names of those animals, are known, and the input data, the face, it's more like you are mapping the face to what animal it is. Is it a cat? If the face is of a cat, you can map that to a cat. If the face is of a dog, you can map that to a dog. So the most important thing about supervised learning is that we are dealing with a label data where each input data point, like a picture of a cat or a picture of a dog, is associated with a corresponding output label or target, like cat, like dog, like donkey. You know, the picture is associated with a label. The picture is associated with a label. And we know the answers. We know the names of these faces of animals, and we want the computer, maybe we can, once we train the computer on the training data, then we can maybe test the computer and show it a picture of a cat and ask the computer, what is this? And then the computer can give us what it thinks it is. Think of it, an easy way to maybe explain it. Maybe, I don't know, sometimes it can be a little bit hard to kind of like know about the labels and stuff like that. But supervised learning, you can also think of it like, say you have a teacher who tells you the right answers, and you learn from examples, where the teacher already knows the answers. For example, if you're learning shapes, the teacher can show you a circle, a square, and a triangle, and tell you what each one is, maybe several of them, and tell you what they are. Then, when you see a new shape, you can say you can say what it is based on what the teacher has taught you. We can go. I want to just try to see if I can go to Google and just try to see if I can find a picture of supervised learning. Supervised learning, and I'll just say supervised learning, and we can see what we get here. Images, and so like this is the one that we're talking about, shapes. Like so this is supervised learning, where we can say we have these images here, and each image here has a label. Like we know that this is a triangle, this is a circle, and and this is an hexagon. These are the labels. We have the images, we have label data. So this is the data, and these are the labels. Like we have, this is a rectangle, that's the label. And we have, this is a circle, it's label data. We have this a triangle, and we also have this as an hexagon. And then we can show the computer like something like this, and ask it what it is, and it's going to say that it's a rectangle. We can show a computer something like this here, and we ask the computer, after training it, we can ask the machine what this is, and it can tell us that this is a circle. And you can see here the computer is trained on different label data. So it's been told this is a rectangle, this is a circle, this is an hexagon, with this label. So it's just been fed in. And then the computer learns, it learns what a circle is and what a rectangle is because it's been told what it is. So it's been showed a lot of circles, a lot of rectangles. So it learns this is how a rectangle looks like because it has been shown a lot of label data. But the machine learning model will also have some text data where after being shown all these images with the labels, we come here and we show it one of the images like a triangle, and we run through and we ask the computer, what is this? We don't now show it the label, and we know what the answer is, but we won't show the computer, and we'll have to have the computer tell us what it is. If it says this is a triangle, then it passes. It means that it has learned very good. If it says that we give this circle and it's running through the model and make a prediction, if it predicts this is a circle, then it has passed. So that's supervised learning. You can also show, easy way is also to show cats and dogs. I was trying to see, maybe I can see 1 year supervised learning with cats and dogs. So, so these are label data. We have cats. Cats look like this. These are cats. So we tell the computer, we give the computer a lot of this. And we show it a lot of pictures of dogs, and we have the labels. Supervised learning is label data. So these are cats, label is cat. These are dogs, label is dog. And we can now come here with our testing data. We can maybe, this is another data that you can also give the computer to learn. Like, it just needs a lot of data to learn and learn and learn. And the data is labeled, like this is dog and this is a cat. Then after you finish training it, now you can show it a picture and try to have it tell us what this is. Like this one, the test data. So we can pass through this through an algorithm and ask the computer what this is and learn through the algorithm, the neural network, and it can say, oh, this is a cat. It's a test, but it can say this is a cat, and it can say this is not a cat. So the goal of this is to identify whether it's a cat or not a cat. So it fed this, it identifies a cat. It fed the other one, it identifies as a no cat. And as you can see, the test data, the labels, and the computer doesn't know the labels, but we know what the labels are. Like, we know this is a cat and things like that, but the computer doesn't know. But during training, we train with a lot of label data, so thereby you can be able to see a lot of them, and then you can know what they truly are due to the label data. So that's that. Before we continue, I just want to mention that in supervised learning, the algorithm is trained on a labeled data set where each input data point is associated with a corresponding output label or target. The algorithm learns to map inputs and outputs by minimizing the error between its predictions and true labels. So once you start training the machine learning model, the neural network, initially it may not get a lot of, when we ask it whether this is a cat, it may say it's not no cats, but it may be a cat. So it's going to make some errors, but it trains itself to get better, It's trial and error, but it trains itself to get better, and then eventually it can be able to identify a higher percentage of right predictions. So the algorithms learns to map inputs and outputs by minimizing the error between its predictions and the true labels, true labels. So common tasks in supervised learning include classifications, that's assigning labels to input data, like trying to say cat, no cat, or regression, like predicting continuous values. Like supervised learning, regression, I can see you, maybe we can see, we can find, it's actually regression and classification. This is good. So I want to actually show you regression first. So regression, so this regression trying to get a little bit of a line here, and regression analysis in machine learning. And you can see we're trying to kind of like try to see regression data. And so pretty much predicting continuous values. I can see here predicting continuous values, like you draw a line here. Continuous values, this is regression, this is linear regression. Continuous, predicting continuous values. So linear regression, so regression. So that's for supervised learning. Then we have unsupervised learning, and in unsupervised learning, the algorithm is trained on unlabeled data set, where the goal is to discover hidden patterns or structures in the data. So when we think about unsupervised learning, I think a good way to think of it is like, say that you are playing with a bunch of toys, and you start sorting them into groups based on how they look or what they do. You are not following any rules or instructions. You are just noticing similarities and differences between the toys and organizing them based on those similarities. Like you may want to put toys with cars in one box and toys of animals in another box, and so on and so on, without anyone telling you what to do. So in machine learning, the computer essentially tries to learn from patterns. It tries to learn and see how a bus, if you want the computer to know a bus, you don't tell it it's a bus, there's no labels. You just show it different pictures of buses, and it's going to essentially learn the patterns. And when you show it another picture of a bus, it could be able to identify or to group that with a group of buses. Like if you show it a lot of pictures of buses. You don't have a label, in the sense that you don't tell the computer what it is, but the computer itself tries to figure out the patterns. And with time, it's gonna classify the buses together, and the umbrellas together, and pizza together, and bread together, without labels, but grouping them, clustering them together. So let's see here, we can say unsupervised learning and see what we get about classifications. Unsupervised clustering, unsupervised learning, unsupervised learning, unsupervised learning. We'll just do that. And so you can see here, the computer just, this is supervised, where we have trying to, trying the linear regression there, but this is unsupervised learning clustering. And here the computer is trying to group this unlabeled data by the color, like these dots of the similar color, they are grouped together. These ones of similar color grouped together. These ones of similar color grouped together. Here, unsupervised learning, again, you can see that it's unlabeled data. We have no labels. So the computer just tries to look at the shape, and it sees a lot of images, through the machine learning algorithm. So if you pass this, it can group this, it can run through the machine learning algorithm, and it can group this to this item here. They all both look alike. Then these ones, they also both look alike, they are grouped together. The hexagons, they also look alike, they are grouped together. This is not labeled data, but the computer learns the patterns, and it can be able to group uh, patterns that look alike, or you can be able to get the patterns from the data, and it can be able to group patterns that are similar together. But the data is not, it's unlabeled data, which is very important. Um, Something I wanted to mention before we continue is that unsupervised learning algorithms can perform tasks like clustering structures, cluttering. I'm going to say that again. Tasks like clustering, that is grouping similar data points together. Like this is clustering, or this is clustering here. We have similar, that's grouping similar data points together. Like these are all same color, these are same color, these are same color, clustering and supervised learning, and also dimensionality reduction, that's reducing the number of features while preserving information. And another type of machine learning is semi-supervised learning. And in semi-supervised learning, the algorithms normally combine elements of supervised learning and unsupervised learning by leveraging both labeled and unlabeled data to improve performance. This approach is particularly useful when labeled data is scarce or expensive to obtain. And another type of machine learning is reinforcement learning. And I think we talked about reinforcement learning earlier in our video. But essentially, reinforcement learning involves training an agent to interact with an environment in order to maximize cumulative rewards. The agent learns through trial and error. Trial and error, and receives feedback from the environment in the form of rewards or penalties. Reinforcement learning is commonly used in tasks such as game playing, robotics, and optimization problems. And I think we're there. We're talking about, I'll just go here, about reinforcement learning. I'll say just view slideshow. And, training an agent to interact with an environment in order to maximize cumulative rewards. And reinforcement learning is commonly used in tasks like game playing, robotics, and optimization problems. And what to learn is that the agent learns through trial and error. It receives feedback from the environment in the form of rewards and penalties. And I think we covered this a little bit earlier in our discussion. So I will go next here to the next slide. And I did find something that I thought was very good for use cases for the different types of machine learning. You can see here we have the supervised learning, and in supervised learning we have classification and regression. In classification, machine learning can be used in supervised machine learning can be used in fraud detection, image classification, customer retention, and also diagnostics. Supervised learning in regression subcategory can be used in forecasting, predictions, process optimization, and also new insights. Then we have unsupervised learning here. We saw about clustering and also dimensionality reduction. And unsupervised learning, the subcategory of clustering, can be used in customer segmentation, targeted marketing, and also recommended systems. And unsupervised learning category for dimensionality reduction, we have meaningful comprehension, big data visualization, and also structure discovery. So a little bit of different areas where in the industry machine learning can be utilized in the real world. We are going to go next, and next we'll talk about what is deep learning. What is deep learning? We saw machine learning, and we're gonna see deep learning right now. And essentially, deep learning is a subfield of machine learning that focuses on the development and training of artificial neural networks, which are computational models inspired by the structure and function of the human brain. What are convolutional neural networks? We'll talk about that here in a minute, but before we try to see about the convolutional neural networks, I wanted to mention that deep learning algorithms consist of multiple layers of interconnected nodes, also called neurons, which are organized in hierarchical architectures. These neural networks are capable of automatically learning hierarchical representations of data, which enables them to effectively capture complex patterns and relationships in high dimensional data. So deep learning has achieved remarkable success in various domains, including computer vision. As, we saw computer vision before, natural language processing, speech recognition, and also reinforcement learning. Some of the key components and techniques in deep learning include convolutional neural networks, or CNNs, and we'll see this as we start coding with PyTorch. But convolutional neural networks, or CNNs, are a type of neural network architecture designed for processing grid-like data, like images. They are characterized by the use of convolutional layers, which hence convolutional neural networks. They are characterized by the use of convolutional layers, which apply filters to input data to extract features hierarchically, like in an hierarchical order. And we'll see that as we continue, but that's something very hard to pronounce, like an hierarchy. So hierarchically. I don't know if I can say that, but I'll move on. So convolutional neural networks, I think I should maybe just go to Google here and we just try to Google neural networks, so we can just have a little bit of a basic understanding of what a neural network is. So we can just Google neural network, machine learning, and I hope we get yeah. So we saw these neural networks. We saw they can be deep, they can be not deep. We'll see convolutional neural networks. We'll also see the recurrent neural networks. But for now, just know that, like, just have a basic understanding of neural networks. So we'll go back to the slides here and we click on view, And well, I want to go to my slides here. We click on view, then we can see the slideshow. Then so another way that another technique that is a key component of deep learning is a recurrent neural network. And recurrent neural networks, or RNNs, are a type of neural network architecture designed for processing sequential data like text or time series. They are characterized by feedback loops that allow them to maintain and update an internal state based on previous inputs. We'll see that as well as we continue with our journey on PyTorch. Also, we have long short-term memory networks, also called LSTM. And LSTMs are a type of recurrent neural network architecture designed to address the vanishing gradient problem and capture long-range dependencies in sequential data. They are commonly used in tasks such as speech recognition, machine translation, and sentiment analysis. And then we also have the autoencoders, and which are a type of neural network architecture used for unsupervised learning and dimensionality reduction. They consist of an encoder network that compresses input data into lower dimensional representation, that's encoding, and a decoder network that reconstructs the original input data from the encoding. And then we have the generative adversarial networks. And these are a type of deep learning architecture that consists of two neural networks, a generator and also a discriminator. And they are trained simultaneously through a competitive process. Generative adversarial networks are used for generating realistic synthetic data, image to image translation, and also other generative tasks. Overall, machine learning and deep learning have revolutionized the field of artificial intelligence, and they have enabled advancements in various applications, ranging from computer vision to natural language processing to healthcare to finance to autonomous systems like self-driving cars. So, they have been very helpful and also very significant in making advancements in artificial intelligence systems. So I have a little bit of a deep learning neural network here. I think we saw that when we're looking at the examples, but I included this here. You can see that we have an input layer here, then we have an hidden layer, then we have the output layer, and a lot of interconnections. We also have another, this one has one hidden layer, this one has 1, 2, 3 hidden layers, and input layer here. You can put the picture of the president here as the input, you pass it through, and the goal is to have this being identified as George Washington or George. But that's the basic idea of it. I just wanted to get you a little bit of a basic understanding and of PyTorch, and also a basic understanding of machine learning and deep learning, and just basic understanding of neural networks. But we'll be able to dig deeper and go deeper when we start to code. Next, I think I will have, I'm gonna stop here now, but in the next video, we'll probably try to see how to install PyTorch in our computer if we have a computer, a big computer with a lot of power to run the PyTorch and also the neural networks. And we'll also see how we can be able to utilize Google Colab to run code and to code machine learning, training, and testing data and networks. So we will start that in the next video. But for now, I hope you found this a little bit more helpful. I think this is gonna be close to the end of the theory aspect, and once we learn about working with with Google Colab, and then we'll start coding, and from then on it's gonna be coding and not much a lot about talking. So I'll see you next time. Thank you. Gracias, happy people.